Welcome everyone to Wednesday Night at the Lab. I'm Tom Zinnan. I work here at the UW-Madison Biotechnology Center. I also work for UW Extension Cooperative Extension, and on behalf of those folks and our other co-organizers, Wisconsin Public Television, the Wisconsin Alumni Association, and the UW-Madison Science Alliance, thanks again for coming to Wednesday Night at the Lab. We do this every Wednesday night, 50 times a year. Tonight it's my pleasure to introduce to you Kim Mueller. She's with the Wisconsin Alzheimer's Institute. She was born in Ridgewood, New Jersey, and went to Riverdale High School right there. Then she went 20 miles south?
35.
35, I stand corrected. To Rutgers University for her undergraduate in psychology. And then she got a master's in speech pathology at Columbia University across the river in Manhattan. And then she came here to UW-Madison in 2005. She also did a PhD program, which she just finished in May. Way to go.
Thank you.
Tonight, the topic is preclinical Alzheimer's and speech. She has a longer title, which she'll give to you. This is something that anybody who has parents, you're watching out for them. I'm rolling the odometer over to 60. I'm watching myself not be able to pull things up. Well, words. Like I used to. So this is going to be interesting, and I think that's why we have such a great crowd here tonight. Please join me in welcoming Kim Mueller to Wednesday Night at the Lab.
What a great introduction. Thank you. Can you hear me okay? All right, thank you. So the longer title of this presentation is Connected Speech in Early Mild Cognitive Impairment, Results from the Wisconsin Registry for Alzheimer's Prevention. So before I go any further, I want to tell you what is connected speech. And connected speech basically refers to everyday talking. It's a kind of a technical term. So I was just at a conference and somebody said, well, what would my speech sound like if it was unconnected? And the answer is that typically when we test language, we do so in a single word way. We have people look at pictures and name them. That's a cat, that's a dog. But connected speech is putting words together, everyday talking, just like I'm doing now. So keep that in mind as we go forward with this talk. And I just want to thank everyone here at Wednesday Night at the Lab, Tom Zinnan for having me. Thank you to Sandy Rotter for getting me here. So I really want to thank, I'm very grateful to be here tonight. So thank you again. All right, so this is Iris Murdoch, award-winning novelist, former President Ronald Reagan, and novelist Agatha Christie. So they all had something in common. They all had Alzheimer's disease, or in the case of Agatha Christie, suspected Alzheimer's disease. But they also had something else in common. They had a very personal biomarker or cognitive marker that was publicly and is publicly available, their speech and their language. And we have this on record for decades and decades prior to the diagnosis of Alzheimer's disease. So in the case of Iris Murdoch, she was an award-winning novelist. She wrote over 26 novels in her lifetime. She died of Alzheimer's disease at the age of 79 in 1999, and this was Alzheimer's disease confirmed by autopsy. And the last novel that she wrote was in 1994, and it was called Jackson's Dilemma. And this novel was very interesting because it got really bad reviews, which was unusual for her. So in the New York Times book review in 1996, the review goes on to say that the writing is a mess, strewn with imprecisions and blatant redundancies. The author of this review also mentioned how she would often repeat the same phrase, like "now suddenly," several times within the same paragraph. So some researchers then took Iris Murdoch's novels and looked at them over time. So this researcher named Peter Gerard in London. And so he looked at her novels at the beginning of her career, at the mid-height of her career, and then this last novel, Jackson's Dilemma, and analyzed the content of her writing and found that over time, by the end of this novel, her content words decreased, her vocabulary became more limited, and she did, in fact, repeat words and phrases much more often by the last novel. And so the authors argued that this is evidence of Alzheimer's disease at play before the diagnosis, before symptoms set in. President Ronald Reagan was diagnosed with Alzheimer's disease 6 years after he left office. And some researchers in Arizona, Berisha and colleagues, they analyzed Ronald Reagan's unscripted speeches from press conferences from 1981 through 1988. And they found that Ronald Reagan's speech over time became less fluent. And that means that he started to pause more often. He used more filler words like well, and non-specific words like pronouns and words like thing and that over time. And this was a significant change over time. So I'm going to play you 2 samples from Ronald Reagan's speeches and see if you can hear the difference. Now, this is extremely subtle differences, so it may be difficult to hear them, but I'll try to point them out as we go. So this first one is his first press conference in 1981.
Circumstances, détente is possible.
Well, so far, détente's been a one-way street, and the Soviet Union is used to pursue its own aims. I don't have to think of an answer as to what I think their intentions are. They have repeated it. I know of no leader of the Soviet Union since the revolution, including the present leadership, that has not more than once repeated in the various communist congresses they hold their determination that their goal must be the promotion of world revolution and a one world socialist or communist state, whichever word you want to use.
Okay, so aside from that being the longest run-on sentence in the history of sentences, and a lot of embedded clauses, it was a very complex sentence. It was pretty fluent, and he kind of knew where he was going with what he was saying. So now we look at a press conference, an excerpt from 6 years later, and this is in 1987, and this is his 41st press conference.
Elliott Abrams repeatedly misled Congress, and yet Secretary of State Schultz says that he's a good man and he can keep his job. Is Schultz right? Can Elliott Abrams keep that job as long as he wants?
I know the statement was made by the Secretary of State, and that is the administration's position. And I know the reference that you were making to the particular point in which he himself volunteered that he had made a misstatement, but I accept the Secretary's statement on this.
Chairman, you're the president in the end.
Okay, so this second sample, very subtly you can hear some hesitations, some filler words like that, which we all use, by the way. We all use these. You can hear me using them now throughout this talk. But from a change, this is a change standpoint from earlier to later, the researchers found a change. Now they did this in a very controlled way. So each press conference, they took a specified number of words per conference. and analyzed it according to those 100 words or 200 words, whatever they used as their standard. So relatively speaking, an increase in filled pauses and pauses over time. So this is the Nun Study, and this happened right here in Wisconsin, in Milwaukee and other areas of Wisconsin. And these researchers studied nuns throughout their lives. And one study of this Nun Study found that by examining the nuns' free writing samples when they were in their 20s, they looked at idea density. So this means how many ideas relative to the total number of words did they express? How rich were their writing samples? So they looked at that, and nuns with lower idea density in their 20s predicted who of those nuns would go on to develop Alzheimer's disease. Not only on cognitive tests did they perform worse 58 years later, but also it predicted who would have the brain pathology of Alzheimer's on autopsy. So something about linguistic ability in early life predicted later life cognitive function and Alzheimer's disease pathology. So here is a picture of a hypothetical mother and daughter. And the mother in this case has Alzheimer's disease, and the daughter is caring for her. So my research question is, can we use that same speech analysis that was used retrospectively with Ronald Reagan, Iris Murdoch, can we use that same analysis with the daughter while she is still healthy and follow that speech over time to see if it is a marker for change? And that's the basis of my research. And the Wisconsin Registry for Alzheimer's Prevention, or the WRAP study, is going on here in UW-Madison. It's been going on since 2001, and it is a cohort of individuals who are at risk for Alzheimer's disease. So they're in their late middle age, they have no symptoms of Alzheimer's disease, we don't know who of them is going to go on to develop the disease, but they're enriched for parental family history. And so we're following this group over time to determine who is going to get the disease and what about them is possibly increasing or decreasing risk. So pausing and to talk about what is Alzheimer's disease. So Alzheimer's disease is defined by the brain pathology. So the amyloid plaques, which are hard, sticky substances, which you can see up there in the yellow areas, and the neurofibrillary tangles, which are clumps of tau proteins that eventually cause the neurons in the brain to die. And this is the definition of Alzheimer's disease, is the presence of these plaques and tangles. Now, Alzheimer's disease is a cause of dementia. Often people wonder, well, what's the difference between dementia and Alzheimer's disease? Dementia is the set of syndromes, and Alzheimer's disease is a cause of that dementia. Alzheimer's disease is the most common cause. There are other causes like changes due to vascular changes from stroke or Lewy body dementia. Alzheimer's disease is the most common. Currently, there are over 5.5 million Americans living with Alzheimer's disease in the US today, and this number is expected to triple by 2050 if a cure or prevention is not found. Alzheimer's disease is the 6th leading cause of death in the United States, and it's the only cause of death for which there is no prevention or known cure for this disease. Alzheimer's disease is not a part of normal aging. It is not inevitable that people will get Alzheimer's disease if they live long enough. It is an abnormal disease, and it needs to be understood, and that's why there's a huge push to try to understand what's causing this disease and how to prevent it or cure it. So the symptoms of Alzheimer's dementia are memory loss that disrupts daily life. So you can no longer live independently when you're diagnosed with Alzheimer's dementia. There's a confusion with time or place, withdrawal from work or social activities, severe challenges in solving everyday problems. Things that used to be automatic are no longer easy to do. And there's a problem with words and speaking, which is my area of interest. It's generally accepted now that Alzheimer's disease is on a continuum and that there is an asymptomatic phase where the plaques and tangles are forming, but there are no symptoms. And this asymptomatic phase could be occurring decades and decades prior to the onset of symptoms. Mild cognitive impairment is the precursor to Alzheimer's disease dementia, or the intermediary stage between asymptomatic and dementia. And the criteria for being diagnosed in a clinic for mild cognitive impairment, or MCI, is that there are cognitive changes that are concerning to either oneself or one's family. One or more cognitive domains are affected from previous function. There's a decline from previous ability, but a person is still functional. A person can still live independently, and that's the difference between MCI and AD dementia, is that they're still functional, and it's possible that compensation strategies can be taught and used effectively at this MCI phase. So it's really important that we diagnose this disease and this process as early as possible. So what do we know about speech and language in Alzheimer's disease and MCI? Basically, as Tom was referring to, as we age, problems with word retrieval are a normal part of aging. Word retrieval becomes slower and more difficult as we age. However, this word retrieval problem is it's a nuisance, but it's not a major disruption to communication. You might not be able to retrieve the word, but it will come back to you at the most inopportune time, hours later when it's no longer relevant, but it does come back to you. Also, it doesn't cause a person to completely withdraw and feel so frustrated that they no longer want to communicate. This is what it looks like in mild cognitive impairment and Alzheimer's disease. The word retrieval problems are so intense that they will occur multiple times within a sentence or a conversation, and they disrupt fluency, like we talked about with Ronald Reagan. Also, the word retrieval problems become so severe that sentence structure becomes less complex and disorganized. And on this slide, that bottom piece about pragmatics in discourse, this refers to one's ability to communicate back and forth with other people. And this part becomes affected in mild Alzheimer's disease, possibly even in MCI, because of that frustration and kind of a quitting of what you were going to say, losing the thread of thought in conversation and getting to the point where you change the topic or you withdraw. So these are the things that we see. We know that in severe Alzheimer's dementia, people can become completely nonverbal and lack any means of communication. So again, just like I said earlier, the declines in language are on a continuum as well with this disease. So connected speech, I told you what that definition is, and this is just an illustration. Currently in research studies or in the clinic, we evaluate language by typically asking people to name objects or pictures. So on the right-hand side, tell me the name of what you see. That's a cat, a ladder. That's not really going to get at what people are feeling frustrated with and are complaining about in their daily lives. How can we do that in a controlled way? One way is by picture description tasks. So on the left-hand side, this is a line drawing, a picture, and some things are going on there. And the question is, tell me everything you see going on in the picture. And then that will then elicit more typical everyday speech and language than another kind of task would. And so that's what I'm interested in my work. And I alluded to this already, but why would we study connected speech in this preclinical phase? Why is that important? And this article was written in 2014, and it asks the question, if we have better methods of identifying the plaques and tangles now. We can see plaques and tangles on PET scans and MRIs. We can see a lot of information, more than we ever could in the past. So we've made great advances there, but we haven't made as much advance in detecting subtle change in cognition that actually affects everyday life. So if we have a drug trial, we want to know, is the drug working in everyday life? That's the question. It's not, okay, the person's staying stable on this neuropsychological test. It's more, is it actually having an effect on everyday life? And so that's my question. Can speech be a possible tool for that? Tool for screening or for disease monitoring? That's one aspect of this that I think is important. So again, this research question I'm asking, can everyday language, just talking, be a tool for assessing cognition and a tool for assessing a functional activity of daily living? That's my question. So I gave you a definition of connected speech. You'll hear me interchanging language and speech together. And just as a speech pathologist, the word speech refers to the automatic process of producing sounds to form words. And that's different from language, which has to do with the rules of vocabulary and the rules of grammar. So these two words are not quite interchangeable. They have different meanings, but in this task, I'm actually looking at both aspects, mechanical aspects, timing, as well as the content of the language. It's also important that you keep in mind, as I talk about my study, that mild cognitive impairment, what I talked about earlier, is a clinical condition that's diagnosed by a doctor. And that's different from what I'm going to talk about, which is early mild cognitive impairment. So something that's not yet diagnosed by a physician, but something that we see in a longitudinal study. So it's almost a pre-mild cognitive impairment state. And the last thing is ecological validity. This is something that we're looking for in our tools. Ecological validity gets at whether or not a test measures what it's designed to measure. So is speech, is a single word task going to measure how someone actually converses? Or my argument is that connected speech tasks might actually be better at measuring an everyday activity. So that's ecological validity. So the first step in doing this work was to review connected language tasks in MCI and AD. What have people done so far, other than the few studies that I talked about at the beginning? And what I found by doing this review was that most of the studies of connected speech were done with people with Alzheimer's disease dementia later on. Very few were done in the mild cognitive impairment stage or earlier. I also found that across studies, there were multiple measures used. People looked at percent nouns, percent pronouns, number of pronouns divided by nouns plus pronouns. I mean, the list went on and on and on. And sometimes it was similar constructs, but different names for these constructs. So there was not a lot of continuity among all of these studies. I also found that picture description was the most common method of eliciting connected language. There are other ways to elicit language, such as tell me about where you grew up. That's a confounding way of eliciting that in a memory impairment kind of disorder, because we don't know then, is it memory of events that's getting in the way? And that's why picture description is a confined task with the stimuli right there in front of the person. And so memory for events and things is less of an issue with a picture description task. So I want to tell you about one other study in particular. This is a study of people with the inherited form of Alzheimer's disease. It's a very rare genetic form. It's involved with a presenilin gene, and it's a very rare form. Usually the onset of Alzheimer's disease happens in a person's 40s or younger. So very rare. But there is a family in Colombia who have this genetic form. It's an enriched family for this genetic form of Alzheimer's disease. So what these researchers did was they studied people who had the gene and then family members who did not have the gene in their early 30s and 40s before any symptoms of Alzheimer's disease. And the people with the gene, the carriers of the gene, showed reduced content in their picture descriptions of connected speech versus those who were not carriers. So this is an asymptomatic cohort, and already the researchers were seeing change in connected speech prior to the onset of symptoms. So this cohort that I'm looking at is the Wisconsin Registry for Alzheimer's Prevention. As I mentioned earlier, I'm going to tell you a little bit more about this group. The goals of the RAP study are to identify Alzheimer's disease in its preclinical phase before symptoms set in, and to identify the biological, health, and lifestyle factors that might increase or decrease risk of Alzheimer's disease. So participants, this is the design of the study. And the idea, if you look at this graph, on the bottom is age, and on the y-axis is cognitive function. And so the idea is that in normal aging, you see that black line, cognitive function will decrease slightly, but not a lot. But then this other trajectory in red is the trajectory of Alzheimer's disease. And so we're following these individuals when they start at a young age. The mean age at baseline was 54 years old. So they're cognitively healthy, no problems. They had a parent with the disease, but that's about all that we know. And so we follow them over time. After the first visit, they come in 4 years later, and then 2 years every visit thereafter. Currently, we're on our 6th wave visit for many of our participants. Currently, we have over 1,500 people enrolled in this Wisconsin study. The last visit, the mean age was 62 and a half. There are 70% women in this group, and the mean age of education is 16 years, so they have at least a college degree on average, a very highly educated group. Their average IQ is also high for average, above average. There are 90% non-Hispanic white. We are working on increasing our diversity of this sample. We have a cohort in Milwaukee. We have a site in La Crosse. So we're trying to sample as much diversity in terms of rural and urban communities as possible. 40% of these people have a gene that is a risk factor gene for Alzheimer's disease, the later onset version. And this gene is called ApoE4. And so it's enriched for that, probably because of this parental family history. But we don't know whether or not, if you have that gene, you could still go on to not develop Alzheimer's disease. So it's a risk factor gene. Your risk is increased, but it's not a definitive like that other study I was talking about earlier. 72% have a family history of Alzheimer's disease. So these participants are extremely giving. They come in and spend about 6 hours with us. And they undergo a fasting blood draw. So we look at all kinds of aspects of risk that we know about in their blood, including the genetic risk factor, their glucose levels, their insulin levels, vitamin B, vitamin D. We're looking at all kinds of things that we know about that may increase risk. We also get other physical measures like blood pressure and resting heart rate. We ask lots and lots of questions. They fill out questionnaires prior to coming in. It takes them a couple of hours to fill out all these questionnaires about their lifestyle, their medical history, their physical activities. What are they doing? What are they doing? If they're retired, are they volunteering? Are they doing computer games? What are they doing for their cognition? Are they in groups? What is their social support? So we're looking at all of the things that you may have heard about in the news about increased or decreased risk of Alzheimer's disease. And they undergo 2.5 hours of extremely detailed cognitive testing. And these are neuropsychological tests that have been validated and used across other studies. And they look at memory, language, speed, executive function, and a global measure of cognition. Also, in this RAP study, I've cited 2 articles from the RAP study that detail how we go about determining if someone is showing signs of this early mild cognitive impairment, or EMCI. So this is a construct that was developed by establishing robust norms within the RAP study. So that means that we're able to look at people relative to themselves and relative to people in their cohort and determine if they're declining over time. They may not feel like they're declining. They may not feel like they have symptoms of Alzheimer's disease or of cognitive decline, but we are seeing this according to our construct. And so the people that I'm interested in are the people that are circled there in red. So people who are cognitively healthy over several visits. They're not declining. In fact, some of them might even be getting better on the tests over time. And the people who are declining, this EMCI group. I just want to tell you a little bit more about RAP. This slide is extremely busy because the RAP study is extremely busy. So there's the main RAP study, but offshoots of that are other studies that are going on. And so because of these other studies, we're able to collect biomarkers like PET scans, MRIs, cerebral spinal fluid, where we can really detect the plaques and the tangles in these controlled ways. And so there's all kinds of other studies that are going on that are offshoots of the main RAP study. Okay, so back to the connected speech task. So I'm going to show you this picture. This isn't the exact picture that I'm using in the RAP study, but it's extremely similar. It's a black and white line drawing. It's very simple. The prompt is, tell me everything you see going on in this picture. And this, we have a very simple $50 digital recorder that we use. And the participants talk into this digital recorder. It's actually a very sensitive digital recorder, so we can hear very, very subtle nuances in their speech. So a participant might give a sample like this. Well, I see a man stuck up in a tree, and then they laugh. Well, a daughter, I mean a girl, and so on. And so this is what we're recording. After we record that, we come back and then we transcribe it. And this is done by a speech pathology student or a speech pathologist. And the transcription is basically writing verbatim everything that they say, including these hesitations and these filler words, clearing their throat, laughing, all of these things are coded in this codes for the human analysis or transcripts, or the CHAT program. So it's a specialized coding method that we then feed into a natural language processor. And this is called Computerized Language Analysis, or the CLAN program. It was developed at Carnegie Mellon University by Dr. Brian McWhinney and his colleagues. And what this does is it allows us to feed these transcripts in and quickly, automatically extract all kinds of measures about speech and language. And so it's a very quick analysis. The transcription part, after training, it takes approximately 15 minutes to transcribe about a minute of speech. So 15 minutes to transcribe about a minute of speech. And then this part, the analysis, takes seconds, basically, to do multiple data points. So the first study I did was kind of a pilot, a cross-sectional design to see, can we just see anything with this connected speech task? And this was done kind of early on when we didn't have a lot collected. Presently, there are over 2,500 connected speech samples that we have. But at the time, we didn't have a lot transcribed. So we looked at 78 people, and we used a matched pairs design. So this means that 39 of them were determined to be cognitively healthy over time, and 39 of them were determined to have early mild cognitive impairment. And this paper was published in the Journal of Alzheimer's Disease in 2016. And what we found was that, in fact, people with early mild cognitive impairment in these 1-minute picture description tasks were producing less content words, and they showed lower idea density, like I talked about with that Nun study. So fewer ideas relative to the total number of words that they expressed. So this is what I found at that point, that cross-sectional point, and this was at their first speech sample. So I wanted to next address this question. Since we found that this is working, or it's possible, I wanted to address that next problem about so many measures that we can extract. How do we choose what to look at when there's so many measures we can look at? And so the way that I approached this problem was by doing a factor analysis. And a factor analysis basically takes all those measures and distills them down into these underlying constructs. And we had a really impressive number of transcribed speech samples, 399. This is a large amount of transcriptions. And there were 399 people who were cognitively stable. So we wanted to do that on purpose. We wanted to look at these measures in people who were not declining. So we separated these 399 people into two different groups. One was the exploratory group, and one was the confirmatory group. So the exploratory group had 250 people, and the other one had 150. And the two groups were very similar, except that the confirmatory group had more people with a family history. I addressed that problem, and I'll tell you about that in a minute. So basically, we found a confirmed factor structure, first in the exploratory group, and then we found it again in the confirmatory group. So that says that this structure is relatively stable. And basically, we're taking all these measures, and we found that they kind of load on 4 different factors. And this is what they look like. There's a lexical factor, which has to do with the diversity of vocabulary used. The content or semantic factor, which has to do with this number of content words, but also this pronoun ratio. So how many pronouns are they using relative to the number of nouns? A syntax factor looks at how complex the sentence structure is. and then this fluency factor, which looks at all of those repetitions and filler words and pauses in their speech in an index way. So now that I confirmed that factor structure, I also confirmed that it was invariant across groups, so it didn't matter if they were family history positive, family history negative, men versus women. The factor structure was the same across those groups. And I looked at the factor structure in stable people over time at 2 time points and found that people who were stable on other neuropsych measures were stable on these factor scores. So that shows that the factor structure can possibly be a reliable way of looking at speech over time. And that was my goal for that study. So the final study then looked at those factor scores, those constructs, in participants with language samples at 2 time points. And we had 264 people. And the question here was, are declines in memory associated with declines in connected language? So the results, first we looked at the demographics of this group. And so we just took 264 people who had language samples at 2 time points. That's all we knew about them at the outset. And when we looked further, we found that 200 of them were cognitively healthy at several time points, and 64 of them had this early MCI construct at the most recent visit. So what else we know about these groups is that the early MCI group had a higher percentage of men, and they were slightly older in the EMCI group. Otherwise, and this is important, the 2 groups were the same in terms of age, level of education, their literacy ability as measured by neuropsychological testing, and their family history of Alzheimer's disease, as well as their ethnicity. So the 2 groups were similar except on age and sex. So I did a linear mixed effects model, and so that basically allows you to look at over time how a group is performing. And so if you look here, the dotted line is the group with the EMCI status. And the first, the top graph, the bottom, the x-axis is age, so as they get older, and the y-axis is that fluency factor. And you see that the dotted line, the group with EMCI, is declining faster on these measures of fluency. So they're becoming more and more disfluent in a faster way as compared to the cognitively stable group. The other piece was that the semantic factor was also significantly different, in that the EMCI group in the dotted line declined faster over time in content, and they produced more pronouns relative to nouns over time. It's interesting, if you look at that graph on the bottom, the EMCI group appears to start higher than the cognitively stable group in measures of content, but then declines faster and more steeply. I don't have a full explanation for that at this point in time. I also did a logistic regression, and what that says is, can we predict who's going to have that EMCI status at the most recent visit? And that's done by a logistic regression. And so what we found was that that fluency factor, again, was a significant predictor of who would go on to be diagnosed with this EMCI construct at the most recent visit. So on the right-hand side is the EMCI group, and that's the amount of negative change in fluency compared to the cognitively healthy group. Also interestingly found that at baseline, syntax or sentence structure complexity was a predictor at baseline of who would then be diagnosed with EMCI at the most recent visit. So this is similar to the finding of the Nun study, where early life complexity seem to be a predictor of later life cognitive function. I don't know that this is the same finding, but it's interesting anyway at this point. Other metrics of the speech sample. I found that at both visits, the group with EMCI produced shorter sentences overall. And they were slower to produce the same amount of words and ideas as the cognitively stable group. So they took longer. So what does this sound like? I'm going to show you or play for you an example of this. The first is a 62-year-old participant in 2013, his first sample, and then that same participant 2 years later. And if you see, I don't know if you can catch this, yes. So this participant at time 2 declined significantly in fluency, so he becomes less fluent over time. He also produces less content-rich speech over time, and his lexical diversity, his word choice, becomes narrower over time. So I'm going to play these samples and see if you can hear the difference. And again, it's going to be very subtle, but you may be able to detect the difference. So this is the first time point. The speech is slightly altered to protect the person's identity.
Tell me everything you see going on in this picture.
Okay, I see a family together in the kitchen with some possible potential accidents. Mother is washing the dishes. She's daydreaming, and the water is running over, and it's spilling in a way that might cause her to fall. And the siblings are not supervised because mother's daydreaming, and the brother is on a high stool, which he probably shouldn't be on, going for the cookies, and he's just about to take a tumble. And sister might be laughing about that. There might be some sibling rivalry there.
Okay, so that's the first speech sample. You do hear some disfluencies there. He says a few times. But now this next sample, there are significantly more filler words like that and hesitations and things like that. So you'll be able to hear that now.
I'd like you to tell me everything that you see going on in this picture.
Okay, so I see a kitchen scene. It's chaotic. Mother has 2 children who are not given line of sight supervision. And so the children are reaching for cookies on the top shelf and eating away, probably overeating on sugar. And then the boy is about to be launched from a 3-legged stool that is tipping over. And then mother appears to be daydreaming about something that looks like a nice daydream because she's smiling. So she's kind of ritualistically cleaning a plate. Simultaneous, the sink is overflowing to the floor. So it looks to me like it's a scene that will soon be complete.
Okay, sorry about that. So if you notice, he does speak a lot more this second time around, but relative to that increase in words, the number of ideas actually went down. So he's speaking more, but conveying less over time. So what does this mean? Well, first, it's really important to note that these individuals have this EMCI construct, early mild cognitive impairment. We don't know a lot about that. We don't know if that is going to then go on to develop mild cognitive impairment, go on to develop Alzheimer's disease. We don't know that about this group. And so that's why it's really important for my next step to look at the biomarkers that we know about. So the amyloid plaques and the tangles. If we have participants who have evidence of Alzheimer's disease pathology in their brain, and then these findings stay and hold, then it will be more convincing about what that means for this tool in the future. The other finding is that this fluency factor, at least at this stage, was the most robust in terms of findings here. And that to me was encouraging, because the other factor that has been typically shown, the content, typically shown to be affected early on in the disease process, is dependent upon the stimulus that's used. And if we can detect changes in everyday speech where we don't need a particular stimulus, but rather it could be a conversation at the doctor's office, for example, or a conversation at home that we tape record, this would be even closer to an ecologically valid measure, an everyday activity. This measure, showing a picture in a confined setting is closer to everyday speech, but it's still not quite. And so if this fluency factor can be translated to an everyday activity that's truly an everyday activity, then it will be even stronger as a measure to use in the clinical setting. Finally, what I found here, which to my knowledge, this is the largest study of a preclinical cohort of connected speech at 2 time points. Usually the sample sizes for this kind of work range between 1 and 30 people. And so this is a large sample, and we have many more to use. And it was feasible to do it this way. To have manual transcription from a student took 15 minutes per sample. But now, with technology improving, the next step would be if we could find an automatic speech recognition tool that would eliminate that step for manual transcription. That would make this tool even better. And so that's another future direction. Things here at the UW-Madison are going on, looking at these automatic speech recognition tools and other machine learning techniques of doing this in a faster way. And so that's also a future direction for this work. I want to bring it back and end with the participants. So they are at an increased risk. They have seen this disease firsthand. They've cared for someone with Alzheimer's disease. We have some control subjects who have no family history, but they're often spouses of a person who cared for a parent. So they have seen the disease firsthand. I would bet that almost everyone in this room has had some experience with dementia or Alzheimer's disease. And so it is not easy to come in and give up a day and put yourself on the line and do these difficult memory tests. It is not an easy thing to do. It's an emotional thing to do. It's an extremely generous thing to do because as you'll hear, this sample, this participant will tell you, they don't expect to benefit by their participation. They do this for future generations. They know that they're being watched over years and that their contributions are going to go far, far into the future. But they don't know that they'll benefit. And so again, that makes it even more heroic what they're doing. So I just want to play another part of a speech sample. So we also collect other parts for this speech sample. In addition to that picture description, we ask open-ended questions as well, which I plan to analyze in the future. But one of them is, tell me about why being involved in the RAP study is important to you. And here's the words from a participant about that.
You know, when you have a parent with the disease and you feel pretty helpless, and I learned about the study, it was a way that I thought I could do something by giving my time. I mean, I didn't really know what I was getting into signing up for it, quite frankly, but I think those of us who have the experience of having a parent with the disease feel so helpless in many respects that being in a study is a way to contribute, and it helps to kind of offset that helplessness. And it also feels like you're being part of a potential solution. Thank you.
So my first thank you then goes to our RAP participants here in Wisconsin. They also come from all over the US. So I really want to thank the participants for what they do for us and our studies. On the slide is all kinds of people who are involved in the RAP study and in my work. And so special thanks to Dr. Sterling Johnson, who is the PI of the RAP study, Dr. Lynn Turkstra, who was my mentor for my dissertation work, and all of the faculty and staff at the Wisconsin Alzheimer's Institute and the Wisconsin Alzheimer's Disease Research Center. Finally, the RAP study is funded by the National Institutes on Aging of the National Institutes of Health. So thank you very much for your time, and I look forward to answering your questions. Thank you. Yes.
Yeah, I was interested in hearing the two different, the one speaker in one stage and another stage of the diagnosis of the MCI. I actually thought that second one was more coherent than the first one. The vocabulary was a couple extra larger words, less evaluative, more descriptive. He seems to have been seeing more in that description than when he talked about it the first time. So I thought that he sounded better for my position than he did the first time.
Yeah, so the question is, the participant example, at the second visit, he sounded a lot more eloquent, and he seemed to get more aspects of the picture. His vocabulary sounded richer to your ear. That's what this gentleman is saying. And so what about that? And so I think that brings up two really important points. First, what I'm seeing is something very subtle and very specific to fluency alone. And so there are possibly not even detectable differences in the amount of hesitation, pauses, timing pauses, use of words like and repetitions that you could barely hear, such as those kinds of very subtle changes. So in this particular case, that is the most robust finding. That's also important because recently this work got some press attention, and one of the questions was, so if I notice this in my loved one, should I be concerned and take them to the doctor? And at this stage, I don't think we can jump to saying that this is noticeable by lay people or by the naked ear. So I think that's two important points. I agree with you. It could be due to the fact that he did talk more in general. So he spent more time on it. And that's the third thing, is that when I look at the mean number of words from time 1 to time 2 in all participants, everybody talks more at the second speech visit. And so what is that? I think it's a couple things. It's a practice effect, meaning that they're understanding the task a little bit more, and they want to give us more of what we want. They're more committed by the second time they come in, and so they're working really hard. Maybe they're concerned about their memory, so they're saying more, they're working harder. These are all my theories in my brain, but I can't prove any of them. But I hope that answers your question a little bit, so thank you. Yes?
So I was just wondering, going forward, your envision clinical use of this? granted it's going to be helpful to have a computer analyzing the speech.
Yes.
Just work in a doctor's office. But you still envision following changes over time with the same individual as being important, as opposed to a guy walks into the office and is diagnosed with preclinical?
Yeah, good question. So the question here is, what do I envision this tool to be used for in the clinic? Is it going to be used for something as monitoring change over time in a clinical setting, or is it just going to be a screening tool, right? And I'm not sure. I think that in no case would a test like this alone be a diagnostic yes or no, you have cognitive impairment. I think that this would be a good screener possibly to then induce further testing. Now, as far as disease monitoring, I could see this, and there is a big need. When I go to conferences, the people that come to my talks or my posters are usually drug companies. And so I think that those, it could be a disease monitoring tool. So you get a baseline of everyday speech and put them on a drug and then see if that everyday speech changes in any way. Gets worse, stays the same, gets better. So I envision it in those two ways, but I guess who knows? Yes?
Do you think this is universal to all sorts of causes of dementia, or do you think it's specific for Alzheimer's?
That's a good question too. Is this universal, this tool, can this, or these findings, can these translate to not only Alzheimer's dementia, but possibly other types of dementia? And that's a really good question. I'm not sure of the answer. What I think that we're finding here, no matter whether it's fluency, whether it's content of speech, the findings all are reflecting a problem with semantic memory, at least in this case. And so it's a problem in retrieving words, and then it gets manifested by disfluent behavior or decreased content, an increase in the number of words. So a problem with semantic memory. Now, these tasks have been used for aphasia, for people who have had a stroke and have a focal language problem. But in terms of differentiating different types of dementia, I think it's promising for the language variants of dementia. So there's a particular kind of dementia, frontotemporal dementia, that is specific to a language impairment called primary progressive aphasia. And so this is a dementia where language is the first thing to go, and it gets worse and worse and worse over time in a very quick way. So this kind of tool would be an excellent, probably an excellent distinguisher between that as well. Yes?
I'm here to talk a little about potential dark side of your work.
The limitations?
You're developing something that's based on everyday language. It could be computerized. We're going to try to do that. And we have a disease that's expensive. We have insurance companies that might like to know things about people that may be headed that way. We have employers who might like to make use of this tool. And even though, as you say, probably shouldn't be used by itself, we've seen this use of other technologies like lie detectors and so forth in the private sector. Are you at all concerned about that?
I think that's a valid concern. The question is, with the advent of technology, and would this kind of tool be possibly used, held against you, like by an employer? Can they somehow analyze your speech and find out that you're declining and those kinds of things? That's a really good question. I know that there's a group in Canada who is looking at, using what we have available in terms of cell phone data, in terms of looking at speech over time. They're not doing it in a malicious way, but so, you know, it's a question. I haven't really contemplated, you know, how to go around that or what that means. I think for our purposes, though, what we want to know is how early can we detect change so that we can intervene as early as possible. The interventions that we have right now for Alzheimer's disease, the memory symptoms are, number one, not very good, and number two, they work better earlier on, before the brain has lost too many neurons. And so the idea is to get it as soon as possible. Now, your question, yeah, that's a good one. Okay, yes?
Can you give us an idea of what the interventions would be?
Yes. So what are the interventions? I can talk about from a communication standpoint, and this is one of my interests as well, is if we know what's happening to language very early on, can we develop non-pharmacological interventions? Regarding pharmacological interventions, there's a lot of things being tested right now, including things that kind of work on those plaques in the brain and try to dissolve the plaques to see if that inhibits the development of the tangles. So that's what's being worked on right now. But in terms of non-pharmacological interventions, there are some very effective interventions for people with aphasia, people who have had a stroke and have a focal language problem. And so that hasn't really been examined in Alzheimer's disease because of the progressive nature of the disease. A lot has not been invested in this early intervention. And I think that there can be some real targeted therapies for improving word retrieval, especially while there's a lot of brain function left. So that's one example. Yes?
It would seem like the main study is closed, but can you tell us what your needs are for more volunteers? And would the presence of Alzheimer's in a full sibling have the same weight for you as in a parent? And
thank you so much. The question is about our RAP study and our recruitment. Are we still enrolling people? And also, what are the necessary qualifications? What about people who have a sibling with Alzheimer's disease, not just a parent? So a few things. First, the main RAP study is still recruiting certain types of people, particularly people who are of color, who have a background of either African American, Native American, and the like. So that's one area that we're recruiting. The other piece now, though, is that we have a new study called the GROW study. And this is looking really at families. And so if we have a participant in our RAP study who has siblings, we're now interested in recruiting those siblings into the study. And eventually, we're going to recruit participants' own children into the study. So following generations of participants. But to further answer your question, as our cohort ages and as participants may or may not go on to develop Alzheimer's disease, we're going to need to replenish our cohort. So we do envision at some point opening enrollment again to just the general public who have a family history of Alzheimer's disease. But having a sibling with a disease is definitely an increased risk. Yes?
What's your take on how, as lay people, we can distinguish between something that should be of concern because it might be some indications of developing Alzheimer's and normal aging?
It's a really good question. So how do we distinguish between issues that occur in our lives that are either normal aging versus something to worry about? And are you asking in a general way, like memory and thinking and not just speech, right? Yeah. And so just in general. And so, you know, so in normal aging, forgetfulness is part of it, unfortunately. So you may forget where you put your keys, those kinds of things. But when it gets to the point where it's difficult to understand the function of the keys, for example, or losing your car and then not knowing how to go about finding the car, those are the kinds of things where we really are concerned. In terms of speech, that's a very difficult one to know because word retrieval problems are a part of normal aging. But again, where it gets to the point where you want to withdraw and you don't want to be with people the way you used to, that might be concerning. And the other surefire way of knowing is what I hear from the RAT participants, which is, I just ask all my friends if they're having the same thing I'm having, and if they say yes, then I feel okay, like it's part of normal aging. So, yes?
How do you measure for the APOE factor? That's number one. Number two, going down to the gentleman who spoke first, why did you choose to have the individual repeat the same descriptor? What was your control there? And then the final one is the analysis still bothers me because I sensed that the individual was analyzing better the second time around, and I would think that analysis would be an important factor in cognition.
Thank you. Okay. First question, how do we test for the APOE gene? And the way we do that is we draw blood from our participants, although you can get that information from a saliva sample as well. But in our case, we draw blood, and at the first wave visit, so the first time we come in, we genotype them for APOE. And it's not only the APOE gene, but it's whether or not they have the 4 allele. And if they have 2 copies of that, one from the parent, one from the father, and one from the mother, then it's at an increased risk. 1 copy is about a 35 to 50% increased risk, and then 2 copies, it goes up from there. So that's how we determine that. We also do other genotyping, which is recent. We got a grant to do more genotyping, so we're learning more about all the genes that may be associated with risk of Alzheimer's disease. But that APOE gene has the most evidence behind it at this point in time in terms of the later onset. So that's how we do that. The second question, the third question was the analysis bothers you because what your take was that he really was getting a full picture of what was going on in that scene. Is that right? Is that what you're saying? That, you know, he really got into all of the events that were happening, and he kind of made inferences about what was going on, like, okay, they're doing this, but it's then going to cause this kind of problem. And I think you're right. Like that's a really interesting piece to look at. And I think that that is important for cognition. And so it does show that he has really good cognition going on. But it's what I looked at was a very specific part about language. But you know, and so his status of EMCI is basically saying that on certain tests of neuropsychological function, which again are very focal tests that may not reflect everyday abilities, but are looking at memory and problem solving and speed, he's not doing as well as he used to on those tests. And then I'm seeing this association with fluency with him, but not necessarily with how he's inferring things or how he's thinking about things in general. So it's another question to ask, I think, another thing to look at in these analysis, which we can, which is fantastic. Okay, the second question. At least I remember there was a second question.
Well, it's a related thing, because perhaps your control might have been
Oh, yes.
if you had two different seeds.
Yes, right. So in all of our neuropsychological tests, one of the tests we do is story recall. So we tell them the same story and ask them to repeat it, and then repeat it a half hour later. And then we do that same exact test 2 years later and 2 years later, and we never change it. And the reason is what you said, that word control. We're controlling for the content of that picture. And so I do think that there will be, and we have seen practice effects where people sometimes even remember the task or remember the items, and they get better on this. But if they are on the trajectory of cognitive decline, that's not really going to be an issue for them in the future. So we do that to control the content of what we're using. But like you say, that also comes with some costs, which are practice effects, basically. So, okay. Yeah?
How many of the volunteers in your original study have dropped out?
Thank you. The question is, how many of our RAP participants have dropped out? And we have this amazing retention rate. Only 10% or so of our participants have dropped out. And for a longitudinal study of this magnitude, that's a fantastic number. Now, why is that? It's because of what that woman said. It's because they've seen this disease, it's horrible, and they felt helpless during caring for their parent. So this is something they can do, and they want to do it, and I think that's why their retention is so high. We also try to really treat them well. We can't afford to pay them very much. They get paid $50 when they come in for all those hours and all of that fasting and all of that they go through. But you know, we do everything to make them feel appreciated. Beyond that, I just think it's the intrinsic motivation. Yes?
Yeah. How many raters do you have that analyze the speech and then code it?
Yes.
And do you have validity measures between raters?
Yeah, good question. How many raters code that speech, transcribe the speech, and code it? So in the history of that, there's only been 3. And the reliability is established frequently. And so 20% of samples are then recoded by another rater, and this is done periodically throughout. So we work on that because there is a subjective piece to this where you may miss something, maybe not subjective, but you may miss something or you may miscode it, and so that's really important that we establish that reliability. Yes?
Yeah, I was wondering on the Nun study and your study, over how many years did you first test them, and then the second time, and are you going to be continuing, you know, as far as the validity of this goes, and how they can, at least in the Nun study, make the projection they did?
Yes. So the Nun study looked at nuns over 60 plus years, and this was just a 2-year interval, my last study. So that's not much. And so it is going to be extremely important to continue this. And as I said, I have over 2,000 samples collected. We're collecting them at every visit. And so at this point in time, I have three time points, and I expect to just continue. And so, like you said, as long as we continue this and see these changes, they might get better the next time. This might go away. So it's really important to continue the longitudinal nature of it. Yes. Yes, in the back.
You used the term early life complexity as it relates to dementia. What did you mean?
So what I meant to say, the question is, I used the term early life complexity. And what I meant to say was early life grammatical complexity. So how complex their language was at early life predicted how their cognitive function was at later life. So the nuns in particular, they wrote autobiographies in their 20s. And it was just free writing and just talked about themselves. And so they analyzed that according to how complex the sentence structure was and how idea dense it was. So some nuns might talk and talk and talk and talk, but convey very few ideas, and we might know people like that in our daily lives. So those nuns who had that low idea density and low grammatical complexity in their 20s were more likely to be diagnosed with Alzheimer's disease later in life. Yes?
Have you or any of your colleagues participated in this and analyzed your responses over time?
Thank you. Yeah, you know, when I hear myself do these talks, woo, I feel like, oh boy. But have I done this? No. And have my colleagues done it? No. That's a really good question. I can say, though, the neuropsychometrists, the people that administer these tests, so we not only have these raters, these 3 raters that transcribe the speech, but then we have 7, 8, and over time it's been over 30 different people who have administered the cognitive testing. They go through that so that they understand how awful it is and how you feel kind of under the gun to do these tests and how difficult they are. And so from that standpoint, it is important that we have that empathy when we administer things like this. And so I kind of know what you mean, but I haven't analyzed my own speech over time, but that would be scary.
Sandy's going to fire it up tomorrow morning. So.
One of the confounding pieces of information that I just heard recently is that within the Nun Study on autopsy, because they do autopsies and all of them, that there were a number of nuns who had a great number of tangles and plaques and yet did not exhibit Alzheimer's disease.
Yes, and this is the puzzle that we're trying to solve. So why is it, even in our RAP study, we see people on PET scan or with their cerebral spinal fluid who have evidence of plaques and tangles right now, or who have evidence of brain atrophy, or who have evidence that they're not using glucose effectively in all parts of the brain as they should be. So we have this evidence, and yet on the cognitive testing, they're doing fine. So what is it about these people? What is it about the nuns who lived a normal, healthy life with no signs of dementia, but then had these plaques and tangles, which we continue to see with people? Why is that? And so one theory is that there's a thing called cognitive reserve, where people have looked at education as a factor for cognitive reserve. Higher education reduces your risk of developing dementia. So why is that? It's possible that additional neurons are being built up as compensatory pathways for cognition. So, but with the Nun Study, they all lived in the same confines. They had the same diet. They had the same amount of education. So it's a really good question. One more in the back.
Are the participants, do you ask them about things they do to stimulate their brain activity, like read, do crossword puzzles, other things that we've heard about in the news?
Yes, yeah. So we do ask those questions every time they come in, and ask questions about what they do. Do they play lumosity? Do they read a lot? How much do they read? How often do they read? do they do physical exercise? So we do ask these questions, and we've seen some associations over time. In particular, there's one published study about people who play games, and we're talking about playing games in groups like checkers and chess and games that are interactive. People who play those games over time are not declining compared to people who don't play those games. So it's an association, though, so we can't say that those games are causing this, this relationship. It's really an association. It could be all kinds of things, but we do look at that. We do see more objective results with people who are physically active. So people who report being physically active, rigorous or strenuous activity, 5 times a week for 30 minutes, people who report that are doing better on the cognitive testing in one way. Also, this researcher, Dr. Okonkwo, he looked at people with high amyloid in their brain. So the group had high amyloid overall. But the participants who were physically active were doing better on cognition with high amyloid than participants who weren't physically active with high amyloid. So wondering if this association might lead one to think that physical activity might be moderating that amyloid plaque burden. So these are interesting things, and we are looking and asking about these and following them over time.